Hello, Assalamu alaikum, greetings, good day, and welcome to Learning Economics. As we are continuing our series Data Analysis using R, today we shall discuss about numerical variables or numeric vectors. Dear listeners, as you know that numeric vectors actually represent whole numbers or real numbers, and these are actually the backbone of data science. We have already used them number of times in our series earlier. However, now it is the time to actually explore them in detail and see what we can do with them in R. So first we start with converting strings into numeric variables, and just for a quick reminder, strings are the data that are usually alphabetic characters and is normally written within inverted commas. However, if we write any numeric value within inverted commas, R takes them as string. Let's see it on our studio screen and then see how we can convert such data to numeric data. But before that, if you have not subscribed to our channel yet, I request you to please subscribe to the channel. And if you have not watched our previous videos in this series, I am giving the link of the playlist in the description. Do watch those videos from lecture 1 onward so that you can onboard yourself with us on this journey of data analysis using R. So let's move to the RStudio screen. So let me show it here. If we write, for example, 5 and ask R about its class, it says it's numeric. But if we write this 5 within inverted commas, it says it's a character variable. That is, it is now a string variable. To convert this string variable into numeric, we have two very useful functions. These are precise underscore double and precise underscore number. These both of these functions come in a package called reader, and reader can be downloaded separately. However, the tidyverse package also has reader package in it. So let's load tidyverse to the library. And as you can see, here is this reader function. So the variable precise underscore double is used when numeric data is stored as string. Like if I create a vector named x with values, for example, 2.4, 3, say 5.1, just I'm readjusting my screen. You can see R has recorded is as character or string. Now, if I want to convert these numbers to numeric data, I will use RC underscore double and X. Now the result is numeric. Let me do it another way. I am creating again a vector. This time I am naming it y, and I am asking it to create using parse underscore double x. So you can see it has created a vector y which has numeric variables 2.43 and 5.1. The other function, that is parse underscore numbers, is used when a numeric value is given along with some alphabetic or some other symbols, and R records it as character. For example, if I change the x variable this time to say pkr, 5 and dollar 10.4 and say 28%. You can see it has changed. Now to extract these values 5, 10.4 and 28 as numeric data, we need to use this parse underscore numbers. Oh, sorry, underscore number, and we will write x. This time I am naming this vector as z, so it has created the z vector numeric 5, 10.4 and 28. This is how we can convert some of those strings that have numeric part to the numeric variable. Now let's talk about another function, which is count. Count is actually used for the counting as per given criteria, and it's very much surprising that a lot of data science can be done with the count and little bit basic arithmetics. We know that deployer package provides us with the tools to perform this count function, and it's a great function for quick exploration and for the quick checks during our data analysis process. So for this, we are again coming to the RStudio screen, and this time we shall use those New York flight data. So let me load that data set. So I will use library and NYC New York flights data. It has been loaded as per our best practice. Let's view this data. Flights, it's some heavy data, so it will take some time. Let's wait. So let's assume that we want to count the number of flights as per destination. So for the destination variable, we have this DEST. So we shall use flight and pipe function for count as per destination. Sorry, the data is flights, not flight. Okay, so it is telling us that ABQ is 254 times, ACK appeared 265 times, ALB appeared 439 times, and so on. We can also combine it with sort. For example, if we want to see the most common values or the most traveled destination, we can use the same and just add sort equal to true. And you know what sort does? It arranges values in descending order actually. So the top value is the most appearing destination, that is most frequently traveled destination, followed by the second most frequent travel destination and third more, and so on. You know well how to arrange it in ascending order. We have covered that in our previous videos. And by the way, if you want to see all the values, you can use these two ways. Either you can add another pipe to it. So yeah, and we say view and just this. It has now opened all those 105 entries and these variables. Or you can also use, for example, instead of this view, you can also use print, and we can say it that the number of those should be infinite. I mean, let me write it with capital, I guess. Yes, so it has now printed all the rows, not just the 10 rows itself. So it's your choice either to view it like this or to print it. If you remember, we also used n for the counting previously as well. We can use that here as well. For that, using n. Let's do it. Flights, and now we say group by destination, so it groups it by destination, and then we say, okay, you have grouped it by destination. Now just summarize, and I am saying number is given n, sorry, and let's say I also want to calculate the average delay time. So I can also do that. For example, delay is equal to mean arrival delay, and I am writing na.rm is equal to true. We also covered this na.rm in our previous videos, but just to give you a quick overview of it, there are missing values in this arrival underscore delay variable, and if there are some missing values, R does not do any calculation on that variable. So by telling it na.rm, we are saying it to remove uh, these na variables from this calculation or from your results. And now just let me go again, just we need to, and now you can see ABQ is the destination. It appeared 254 times and average delay time was 4.38. For example, this AUS destination, it appeared 2439 times and average delay time was this. So in this way, we can use N or count functions for counting. And there are a couple of variants of both n and count that are quite useful. For example, first of them is n distinct, which counts the number of distinct or unique values as per the given criteria of one or more variables. For example, if we want to figure out which destinations are served by unique carriers or by distinct carriers, we can do so by using n distinct functions such as flights pipe function, and we are grouping it by destination, and then using this pipe function we are saying summarize, and let's say we are creating a variable CA and it is n underscore distinct and CARRIER. Just let me check the spellings. CARRIER. CARRIER. Yes, it is fine. And I want to arrange them in descending order as per my newly created variable. So I would say it to pass on this information to arrange is, and then DESC descending, DESC for descending order, and descending order as per this newly created variable CARR. Now you can see this ABT 7 distinct carriers travel to this destination. DCA 6 distinct carriers travel to this destination, and so on, and these are arranged in descending order. This error message appeared because I did not close the last bracket that needed to be closed. Yeah, so this bracket remained open and it appeared. So thank you all for self-correcting this. Now there is a one quick question for you. If you are asked to tell how many flights were cancelled with respect to each destination, how will you do that? Pause this video, think about it for 2 minutes. Meanwhile, we return to this answer. Okay, so for those flights that were cancelled, the departure time should have NA not applicable or missing value, and we need to count those NAs. If we will be able to count those NAs, we will exactly know how many flights were missed. And since we are interested in counting these as per destination, so we need to group these by destination first. This is how we can do this. Bit information about how your variable is constructed can be very helpful, but not only just very helpful, but I would say is necessary for an effective data analysis. So let's do it. So we say flights and use the pipe function. Then we group them by destination and we use the pipe function so that this information is passed to the next, and then we construct a variable uh, cancelled. How? We use summarize. Okay, and use the variant of n, and this is the name of the variable. You can give it any name, and how to construct it. I want the sum, that is the total, is dot na in departure time. And yes, I guess all the brackets are closed, but let's go. So now it has counted na as per in the departure time as per this group destination, and shows that all those flights that were destined to ABQ, no flight cancelled. 20 flights that have the destination ALB were cancelled. For the destination AUS, 21 flights were cancelled, and so on. So these are some very useful variants of n or count function that can help us analyzing the data. Now let's move to the recycling rule. We have discussed the arithmetic operations in our previous lecture and also in this lecture to some extent, but we need to talk briefly about recycling rules which determine what happens when left and right hand sides have different lengths. For example, on the R Studio, if I just change this vector x, for example, to say 2, 3, 5, 8, 9. Okay, and C for the column. Now it has changed 2, 3, 5, 8, 7. And I now say x divided by, let's say, 2. Just stop it. The length of x is 1, 2, 3, 4, 5, whereas the length of the other side of the function is just 2. That means length is 1. The lengths are not equal. R will apply recycling rule. How? Let's just first get its result. It has divided this 2 by 2. Answer is 1.03, 1.5, 5, 2.5, 7, 3.5, 8 divided by 2. Answer is 4. What R actually does in these cases, R compares the length of both and extends the length of the shorter using the same sequence until it becomes equal to the length of the larger, and then applies that operation. What I mean to say? I mean to say that in the background, R has actually divided it with a vector which has 5 repetitions of 2. So now they both have become equal in length. Right hand side or left hand side, x and this column have become equal in length, and x have and R has divided element by element. You can see it more if we do the multiplication. For example, we are multiplying it with a vector 2 and 3. Now again, x is of length 5, this is of length 2. What will happen? It has given us a warning message that the length is not same, but R does not give this warning every time. R has produced the results and given us a warning this time, but R will not give the warning every time. However, it will produce the results using this recycling. What it has actually done, x is 2 multiplied by 2, 4. Next number 3 multiplied by next number 3, 9. Then next number 5 multiplied by 2. Next number 7 multiplied by 3. Next number 8 multiplied by 6. So effectively, R has done this. It has extended this small vector 2, 3, then extended this 2, 3, and then extended so that it became equal in length and multiplied, and the result is before us. This is how R handles such situations. Sometimes can lead to some very surprising results. For example, if I use filter on the flights data, month equal to say C1 and 2. What output will it generate? Need to write double equal to. Okay. What output will it generate? The results are very surprising, by the way. It has not filtered all the values that have month values 1 or 2. No, it has not done so. There are 25,967 more rows except these 10. But I can tell you that it has not done so. In fact, it has done what it has done is very surprising. Because of the recycling rule, it finds flights in odd number of rows that departed in January and even numbered rows that departed in February. So for all the odd numbered rows, it used this month equal to 1. And for all the even numbered rows, because the number 2 is at position 2, so it has applied this for even number of rows and filtered only those rows in which are in even number and have the month 2, that is the month of February. So we can use this practice of R in our own for our own purposes, but we can also be misguided if we do not have this information. That's a useful thing to keep in mind. Now let's talk about minimum and maximum. The minimum and maximum function, as you know, return to the minimum value of the variable or maximum value of the variable as we use them. However, these functions can also work with the pair of variable. That is, when we compare across two or more than two variables. For that, we need to write p before them. That is p min or p max. And we need to have at least two or more than two variables for this. Now let me create a new data frame using tribal function. I will explain this function later in some other video, but for now it is a function that is used to create any data frame in the form of rows and columns. And for naming the column, we use this symbol before the name. So I am naming x and y, and then I can write the values. For example, 1 in x and 2 in y, then 3 in x and 7 in y, then let's say 10 in x and 4 in y, then let's say 5 in X and NA in Y. And now you can see this has been created. If we view this, this is X values, these are Y values, and data frame has been created. Now, if I want to see the pairwise maximum values or minimum values, I can do so. And you know, these maximum and minimum function are the part of mutate functions. So let's see how we can do this. Okay, so mutate, and then within mutate, I am creating a variable mini, which is pmin. Then I need to specify which variables I want it to consider. For a large data set, there could be multiple variables. And so we need to specify which variables to compare for picking the minimum value or for picking the maximum value. Also, we need to tell it that na.rm is equal to true. And let's write the same for maximum. So P max X and Y and NA dot RM is equal to true. Okay. So now it has returned that it compared these two and say the minimum is 1, maximum is 2, compare these two. The minimum is 3, maximum is 7, compare these two. Minimum is 4, maximum is 5. Compare these two and said minimum is 5, maximum is 5. I told you earlier that once you have missing value in the data in a variable, that is NA in some variable, R will not perform any function. And to prevent R from this, we included these extensions that NA.RM true. If we do not include it, for example, in this case, what will happen? Let's see. It has returned to the minimum value has returned to NAB. Just one more thing, if I do not write P over here, what will happen? And just think about it before we get the output actually. So 1, 2, 3. It has compared this whole data set and then picked up the maximum value and minimum value. So it has compared all this and said that, yes, this is the minimum value in this whole data set, in this whole data frame. And this is the maximum value in this whole data frame. Now, the next thing that we are going to do in order to understand the operations that can be applied on numeric variables is modular arithmetics. Modular arithmetic is the technical name for the type of the division that we used to do in our earlier classes, at primary school level, where the answers would have been in a whole number, and the divisor and the remainder. So this modular arithmetic is just the name of that kind of the mathematics. In R, this does the integer division and this computes the remainder. For example, I say for a number series 1 to 10 divided by say 3. So 1 divided by 3, we need to multiply 3 with 0, and we put 0 over here. 1 minus 0, our remainder is 1. For the 2, again we need to multiply 3 with 0, so that results in 0. So 2 minus 0, the remainder is 2. For the number 3, we need to multiply this divisor 3 and this dividing number 3 by 1. that results in 3. So 3 minus 3, remainder is 0. So this is the result. These are the results of those reminders. But if we just add this line in between, now it gives us the integer division, that is 1 divided by 3, 0. That is 3 multiplied by the 0, and remainder is this 1. 2 divided by 3, we need to multiply 3 by 0, and the remainder will be 2. For 3 divided by 3, we need to multiply 3 by 1, and the remainder will be 0, and so on. And this is something very useful and very handy sometimes. For example, in this flights data set, if we want to break this schedule departure time or schedule arrival time into hours and minutes, as I told, this 515 means 5 hours 15 minutes morning time, AM time, and 529 means 5 hours 29 minutes in morning time. For example, this 11:30 means 11 hours 30 minutes morning time, and similarly this 15:55 means 3 hours 55 minutes in evening time, PM. How we can use this arithmetic division to break these into hours and into minutes? We can do so using flights pipe function, and then we need to calculate new variables, so we will use mutate. First variable is r, and that is scheduled departure time. We need this divided by 100, and second variable is minutes, MINU, and this is scheduled departure time, and by 100. Oh, I must specify either the place so that I could have viewed it over here, or I must have used dot keep with it. So just let me try to do it again. Okay, and I said dot keep is equal to used. We have used this dot keep function before as well, so I'm not going to explain it. You can watch our previous videos for the explanation. Now you can see 5:15 has been broken into 5 hours and 15 minutes. 6 is broken into 6 hours 0 minutes. 588 broken into 5 hours and 58 minutes, and so on. So this is how you can use uh, uh, this modular arithmetics for your own use. Now, towards the end of this lecture, we discuss something about rounding. Rounding is actually used to round off a variable which has some decimal places, so we can round it off to the decimal places that we like. For example, I say round, let's say 23.456. So it rounds it off to 23. And if I say round the same number and then write 1, it will round off to 1 decimal point and will return 23.5. And if I say round it to 2, it will round off to 2 decimal places and returns with 23.46. However, what happens if I write -2 or -3 or -1? For example, I just extend this variable. So 1, 2, 3, and I say round it to -1. So it will round it off to nearest tens. So the nearest tens are 120. And if I write -2, it will round it off to nearest hundredth value. So the nearest hundredth value is 100. This is how we can use this rounding function. And one last small thing, I'm sorry, one last small thing remains, that is cumulative and rolling aggregates. R basically helps us calculating those cumulative aggregates and cumulative products. Let me do it for you for this X. So I write cum sum and X. So X, remember, this is the X 2, 3, 5, 7, 8. Now its cumulative sum 2 is 2, 2 plus 3 is 5, then 5 plus 5, 10, then 10 plus 7, 17, then 17 plus 8, 25. Similarly, we can calculate cum product as well. So cum and PROD. Now it has multiplied 2, and then the next number 3 is multiplied with the answer 2, that is 6. Now next number 5 is multiplied with the answer 6 into 5, 30. Next number 7 is multiplied with the previous answer, which is 30. So 30 into 7, 210, and so on. It is really a helpful function, especially in statistical analysis. We need to calculate the cumulative frequency of some variable sometime. So that's all for the numeric variables. You can explore more yourself by experimenting, by playing with different kind of the functions. You will explore, you will be able to explore their functions in much more detail, and that will also help you retain all this knowledge. Remember, practice is the key, and liking and sharing our video and commenting on our video to tell us what you want to learn more about R is also a key. So with this note, thank you, take care, and bye-bye.